Okay, here's what we got. So we're going to use an application type problem using using equation of circles, and this is an application applied to finding the epicenter of an earthquake. So what we have here is we've got 3 stations, and it's got their locations, and so these could be in miles, right? Miles west, miles south, or miles north or east. And these are the distances that those stations were from the epicenter of the earthquake. Now, so we know that if we were to trace a radius of these miles, then we know that the epicenter is located on that circular path. But we don't know which direction, okay? So to find the epicenter using the distance, which is again our radius, right? And the center of the station where the stations are located, we can find the epicenter by first drawing out the maps or the radius on a map. Oh, bless me. Okay, and what we can do is we can plot the circles. Okay, now again, my graph is not the best, but again, it makes the point that, hey, if we can plot the circles using the equation of a circle, the center radius form, we can plot this circle. So this station A is right here. So this is station A. And so this is the radius. We know that the epicenter is somewhere on this circle. Just don't know where. And then station B is located here. And so here's the radius that we constructed based on its distance. And then the final, or excuse me, here. And then the final one is here, located right here. And this is station C. And we know, based on its radius, that the epicenter is somewhere along this path. And so since we know that the epicenter has to be on the path of all 3 circles, then all we have to do is look for where the 3 circles intersect. And they intersect right here. And so this is 1, 2. Okay, now, let's show that it actually is 1, 2. So what we can do is we can take the equation of a circle for each one of these. So this is going to be x minus 1 squared plus y minus 4 squared equals 2 squared, right? And we can do the same thing here. We can do x plus 3 squared plus x plus 1 squared equals 25, right? So we can put 4 here, since it's r squared. And then we can do, for the third one, x minus 5 squared plus y, oops, there's 2 x's there, this is y minus 2 squared equals 16. And what we could do is we could plug in this point, 1, 2, in each one of these. And so let's do the first one. If we do this one and we just plug in 1 and 2 for x and y, we get what? 1 minus 1 is 0, right? And 0 squared is 0. And then we get 2 minus 4, which is negative 2 squared, which is 4, and we get 4 equals 4. And so it checks. And again, if we plug in 1, 2 here, we get 1 plus 3 squared plus 2 plus 1 squared equals 25. Well, this gives us what? 4. 4 squared is 16. 16 plus 3 squared is 9, and 16 plus 9 equals 25. Check. And then lastly, we put in 1 here, so 1 minus 5 squared plus 2 minus 2 squared equals 16. Well, 2 minus 2 is 0, so this is going to be 0. Okay? And then 1 minus 4, or 1 minus 5 is negative 4 squared, which is 16. And so they all check. So we just verified that indeed the epicenter of the earthquake is located at 1, 2. And that's it.